Hello and welcome to this video, final video of week 2, where we will discuss a notion of a generating set. So let us start with a definition. So again, we have vector space V, and S is a subset of V, and we say that S generates V or spans V if span of S equals to V. So this is the definition of a generating set. And why is this important? This is important because if you only have S, then by making all sorts of linear combinations, we can actually create the entire space V. So let us now look at examples, and this time as an example I will take a space of polynomials of degree at most 2. We already saw this in the video where we considered subspaces, so I hope this example will not be difficult for you. Assume that S generates the space. Can you give me an example of such set? Think about the easiest example possible. Think a little bit about it and then we will continue. Of course, the easiest what we can come up with is this set. And why? And how can we see that it is a generating set for P2R? Well, because if F belongs to P2R, then it is a polynomial fx, which can be written as a2x squared plus a1x plus a0, which you can also write times 1. And all polynomials have this form, so by choosing different coefficients, let me add a0, a1, a2 in R, we can obtain all possible polynomials in P2R. So this set S is a generating set. But we can also ask ourselves, is it the only possible generating set? And you can imagine that actually one can come up with many more different generating sets. And now I will give you an example of one such set. So this is another set which I called S1. The first two polynomials are the same, but the third one is different. And in fact, this is the beginning of a very important sequence of polynomials in mathematics, which is called Chebyshev polynomials, after a very famous great Russian mathematician Chebyshev. So this is also a generating set. How can we see that? Well, let's again write this function fx, which is a polynomial of degree at most 2. I keep saying at most 2 because a2 can be 0 and then it can be polynomial of degree 1 or even of degree 0 if both these coefficients are 0. So polynomial of degree at most 2, and we have to be able always to write it down as a linear combination of the Chebyshev polynomials. So it means that we have to be able to find coefficients T1, T2, and T3, these coefficients, such that by varying these coefficients around the entire real line, we can obtain any polynomial with any coefficients here. So is that possible, and how can we show that this is always possible to find such T1, T2, T3? Well, basically it is the same question as the question that we already saw when we studied linear combinations. Is this polynomial a linear combination of these three polynomials? And the answer to this question can be obtained by writing down and solving a linear system. For example, all the terms that correspond to power 0 on the left must be equal to all the terms together that belong to the power 0 on the right. So the very first equation for our coefficients will be T1 minus T3 is A0. So you can proceed this way and complete the linear system and see whether S1 is a generating set. Write it down and then I will continue. So here the linear system is completed, and here how it looks like. And you can see that whatever A0, A1, A2 you have, you can always find the corresponding coefficients T3, T2, and then T1. So that means that there always a solution T1, T2, T3, and from that we make a conclusion that S1 generates P2R. So I hope that was clear. Thank you very much for watching this video.